Practice problems. A turtle walks 60 meters at 210 degrees, then 50 meters at 45 degrees west of north, and then 60 meters at 0 degrees. What was the turtle's final displacement? So what we got to do is look at each one of these three situations, that one, and that one. We got to kind of draw it out to see what it looks like. Split it into its x and y components, or its east-west and north-south components. Same thing, right? And then we got to use those to figure out, to make one final triangle, and then use that to find the displacement. That's kind of the way we go through these every time. Okay, so first off, let's figure out what this first one looks like, 60 meters at 210. So I'm going to draw a little Cartesian plane here. And 180 degrees would be to there, right? So this goes a little bit farther. So all I got to do is go 210 minus 180. So 210, do that again, minus 180 is going to be 30 degrees from there to there. And that's going to be 60 meters is what that arrow would look like. Yeah, okay, that's probably long enough. All right. Now, what we want to do is split this up into its x and y components. So let's go ahead and do that now. I'll draw the x component. I'm going to make that, let's say, red. And I'm going to make the y component, make that green. All right, so right off the bat here, let's figure out the x component. That's going to be, so the distance will be, and dAx, we're going to call this situation A. Or the first part, I mean, is part A. So dxa, or dAx, is going to be equal to 60 meters times cosine 30 degrees. So just like what we did above, right? And then dAx is going to be equal to 51.96 meters. All right, so that's number one. We figured that out. Now let's figure out in green here what the y component was. So the y component's going to be, I'm going to just pause it and put it down and then move on. Okay, so that's what you get for the y component of that one. So part one, we got the first kind of part of his walk done. I want you guys to pause it now, though, and see if you can go ahead and do the second part and the third one. Third one should be pretty simple on your own. So I'm going to pause that right now, and then I'm just going to pretty much pop it up on your screen here with the answers. So go ahead and pause it now. Okay, so there's B and C done. One thing I kind of forgot in the last one, though, is I didn't put west and south at the end of this. So you can see here, right, it says 51.96 west. That's going to matter when we add these all together in the end. We want to make sure that those are vectors. Okay, so B, hopefully you got this kind of figured out with the west of north. It wouldn't actually matter for this one because it'd be 45 degrees the other way too. Yeah, but just look that over, make sure you got the same type of thing. Now really all we're going to do is add all the red ones together, all the green ones together, and then we're going to make a new triangle out of that. So let's go ahead and do that. So I'm going to write down D. I'm going to say dr for the resultant vector, and then the x component of that. So that's what we're trying to get here. So all these added together will be the x component of the resultant vector. That's why it's an r. You can really call that whatever you want, though. I'm just kind of trying to try to stay consistent here. Okay, so that's going to be equal to dAx plus dBx plus dCx, just adding them all together. And technically, these should all be vectors, right? So if we do that, drx is a vector. So dAx, that's going to be negative, though, right? That's this one. So that's going to be, it's west, so it's going to be negative. So we're going to say negative 51.96 meters plus, now this one's going to be negative as well because it's going west, so 35.36. Oh, and negative, yeah. and then plus. And you can kind of tell that this is really subtracting, right? I'm just doing this to stick with our formula. You can just go, yeah, hopefully you get what I mean there. And then the last one, the last x value is going to be c, and that's all east. So that's and it's positive, so that's going to be plus 60 meters east. All right, if you add those all up, this would be, you get negative 27.3 meters. So that really just means 27.3 meters to the west. Okay, so that's the first component. Now the second one, maybe I can have room to write this over here. So now we've only got two green ones, right? Two north and south. So that's going to be just dry is going to be equal to day plus dby, because dc didn't have anything to do with the y component. So if we do that, we got dry is equal to, the y component of the first one was 30 meters south, so that's going to be negative 30 meters. And then plus, and then this was north, so it's going to be plus 35.36. So this is going to be our y just 5.36 in the positive direction, so that's going to be north. All right, we're almost there. Last one, we got to take those two, and we got to make a new triangle of that. So I've got this one going west. Oh, I can't draw a straight line. Okay, so that goes west, and that's 27.3 meters. And then tip to tail, this one's going north. I gotta draw that a little lower. Pretend that bump's not there. Okay, and then tip to tail, the next one's gonna go just 5.36 north. So I'm gonna write. Okay, I got tired of trying to make straight lines, so there you go. I used the other program to do that. Okay, so now just using Pythagorean theorem, we can find out that the vector, or the magnitude of that is going to be the square root of 5.36 meters squared plus 27.3 meters squared. So D is going to be equal to, so I get 27.8 meters. Okay, and you think we'd be done by now, but we're not. So that's what our magnitude is. This is 27.8 meters. Now we just got to figure out what this is, what our angle is. So to do that, what we have, really we could use anything we wanted, but let's use the two side lengths, or the two components. So this is going to be tan theta is equal to, it's going to be opposite over adjacent, so 5.36 meters over 27.3 meters. So theta is equal to the inverse tan of that. So theta is going to be equal to, so that ends up being 11.1, or just 11 degrees. All right, finally, we get to just write our answer down. We're there. All right, 27. I'll say displacement of r, the resultant vector, is gonna be 27.8 meters, and then it's gonna be 11 degrees. Now this whole thing, when people get mad about what to do here. North, and that's west, So this is coming like of the west. So it's going to be north of west. Okay. Hopefully you guys could follow along with that. I know these ones are a lot of steps. Well, it took 10 minutes just to do the one question, but yeah, that's the kind of questions we're at now. So I want you guys to go ahead and do the handing assignment for me. For extra practice, there's problems on page 88 of the Pearson textbook. You go ahead and do those too. I got a feeling you might not want to though, but if you do, that's great. Yeah, so I'm going to end that video there.